Today we're going to do Unit 2, Section 3, Solving Linear Systems Using Elimination with two variables. This is my favorite. I prefer this over substitution. And with two variables, it's not that bad. So let's go ahead and get started. The first thing you want to do is try and find if any of the variables, in this case x or y, already have the same coefficient, or the number in front, right? So if we notice, the x's aren't the same, so we don't want to use that. At least not right now. But the y's are the same number, and even better, they're already opposite signs. So I have a +2 and a -2. That sets us up for a perfect elimination problem. So I'm going to go ahead and just draw a line here and combine like terms. So I'm going to add or subtract my numbers. So I have 1x plus 2x, I get 3x. I get 2y minus 2y, those go away. That's what I want. So if you want, you can do 0y, or you don't have to, it's fine. Equals, I have -7 plus 16 is 9. Now look at that nice, easy, simple equation. We can solve for x really fast. From here, I just divide by 3, and I get x equals 3. Wow. And that's it for, we got x. We're good. Now I can take that x and plug it into either equation, right? So let me erase all this. I can plug it into this x or this x and solve for y, and I'm set. I'm going to go ahead and put it into the top one just because there's x by itself. So I go ahead and put it in parentheses. So there's 3, that's my x, plus 2y equals -7. Well, I can't do anything, so I just have 3 plus, I'm just going to write it again. So I need y by itself. I'm going to move this over here and do -3. That gives me 2y equals -7 minus 3 is -10. Divide by 2, y equals -5. So we have x, we have y. We're done. Much faster than substitution, which I hate, but it still works if needed. I just prefer this method. So of course we're going to write it in the right way, the correct way. So we have parentheses, x, comma, y. That's our final answer, and we're done. Elimination is my favorite for these. Alright, moving on to the next one. Now in this example, I did this on purpose, of course. Neither x's or y's have the same number. So we have to make them the same. And we want one of them to be positive, one to be negative. So it doesn't matter which one you pick. You can do either one. Me personally, I prefer just to pick the two smaller numbers. It's just simpler that way if you have smaller numbers. So I'm going to go ahead and do the x's. So to do that, I need to go ahead and multiply my top equation by the opposite. So I want this to be times 2. Okay. And then I want the bottom one to be times the opposite, so 3. But I'm going to go ahead and make this one negative. It really doesn't matter which one you do. So I'm going to go ahead and do, oh, not negative, same thing with the answer. -3, okay? So from here, I'm going to take the 2 and distribute to all of these numbers. I'm going to take the -3 and distribute to all of these numbers. And I'll go ahead and write my two new equations. So 2 times 3x is 6x. 2 times 5y is 10y. 2 times 32 is 64. Okay, now I do the bottom one, same thing. -3 times 2x is -6x. -3 times 3y is -9y. -3 times 20 is -60. Now I can combine these just like I did on the first one. So my 6x minus 6x is 0. We don't have it anymore. Great. 10y minus 9y is just 1y. And 64 minus 60 is 4. Look at that. We already got y. Off to a good start. Now I can plug that y into either one. It doesn't matter. I'm going to go ahead and do the second one. So I have 2x plus 3 times the 4 that we just got equals 20. Of course, you distribute first. So 2x plus 3 times 4 is 12. Subtract 12 to move it over here. 2x equals 20 minus 12 is 8. Divided by 2, x equals 4. You got it. So we have parentheses, x, comma, y. Oh, look at it, they're the same number. Just noticed. Cool. So that's elimination for two variables, two equations. Now let's go down here and look at these special solutions. Things that occasionally happen but not too often. So I'm going to go ahead and start the same way. Notice, again, my x's or my y's, neither one are the same. So I'm going to go ahead and pick the two smaller ones. So I'm going to do x again. So I'm going to multiply the top one by the opposite. And actually, I don't even want to do that. I can multiply 2 by 4 and make it 8, which means I don't have to touch the second one at all. This would actually save me some time. So if you can, I can do negative 2 times 4 and get negative 8. Then I have them the same number with one positive, one negative. That's what I want. So sometimes you don't have to multiply both. So if you can do that, I would do that. That was a terrible arrow. But anyways, distribute the 4 like we did. So 4 times negative 2 is negative 8x. 4 times 3 is 12y. And 4 times 8 is 32. And the second equation, I didn't have to change because it's already 8x. So I'm going to go ahead and just write it down here. And then we can combine like terms, add it, whatever you want to call it. Either way, the x's cancel, right? They're 0. Now look at the y's though. We have 12y minus 12y is also 0. So I have 0 over here, nothing. If everything goes away, it's all 0. 32 plus 20 is 52. Now, of course, just like we did earlier, this equation is false, so I have no solution. And I'm done. I don't have to keep going because there's nothing else to do. So if all your variables go away because they're all 0, then that's it. You get to stop. So here, same thing. Notice I can multiply that negative y times 2 to make it negative 2, right? But since I want one negative and one positive, I'm going to go ahead and multiply by negative 2 to switch the sign. Because again, I don't have to touch the second one because then it's already 2. So that's great. So the top one, I do distribute, right? Negative 2 times 4 is negative 8x. Negative 2 times negative y is positive 2y. And negative 2 times negative 5 is 10. Now I just rewrite the second equation. And look what happens. Everything, right? 8x minus 8x, 2y minus 2y, 10 minus 10. I have 0 equals 0. So because that statement is true, 0 does equal 0. I would have all real numbers, right? And I'm done. Sweet. You could also write infinitely many solutions. So either one. Because all real numbers, I mean, yeah, that would be kind of infinitely many for the most part. Not entirely, but yes, that would be your two special equations or solutions that you could have. So you have one of those, or you just have a simple point where they cross. But either way, that's it for the notes.